Hi pre-calc, let's do another money problem. Now this one's going to be a little less straightforward than the first one. So let's see what we got. We have initial investment is 500. We're missing the percent rate that it's being compounded continuously. And we want to know how long it would take for our initial investment to double. But we are told the amount of money we would get out after 10 years. All right, let me write the formula down again, and I'm going to write it in terms of money. So that's the A equals PERT. Okay, so if I just put in what we have so far, so we have the A, 1505. We have the P, 500. R is not known. That's the annual percent rate. Time for this amount is 10 years. So as you can see that from what is given, this is solvable because we only have one unknown. Remember, E is not an unknown. The value is 2.718. It's around there. So we just have one unknown here, so we can solve this equation. So let's go ahead and solve this for R. The first step is going to be to isolate the exponential, so you have to divide off the 500. Okay, some of you may reduce this, some of you will leave it like this. It's just up to you, your preference. Okay, now we can take the ln of both sides. We're going to put the natural log of both sides. Alright, that allows us to bring our log properties, that allows us to bring the exponent down in front. Okay, ln, we know that goes to 1. We're almost there. We almost have R isolated. So to get R isolated, you just need to divide the 10 off to the other side. Okay, so now we'll divide the 10 off. And we'll be able to solve for R here in this next step. And I know I'm repeating myself, but this is really important. You have to close this side of the parenthesis on the log, otherwise it will also suck in the 10 when you put it in your calculator, and you don't want it to do that. So if you don't quite understand what I'm saying, just make sure you watch carefully when I plug this in. So I'm doing ln. I'm going to do 1,505 divided by 500. Now notice here, this is the important part. I'm going to close the bracket. And that says that that's all the log is taking. It won't take anything else. Now I'm going to divide it by 10. Okay, and let's do, you know, when you're doing the, when you're solving for any part of the exponent, I mean, time, you can keep that with not a lot of decimals, but R, I would do at least 3 decimals on that. So let's do R equals to 0.110. Okay, so we could then just say 0.11, which would then be, as a percent, 11%. All right, so we have our first part of the answer here, that the percent, the annual percent rate is 11%. So we've moved it from a decimal back into a percent. Remember, when you go to a percent, you move 2 units to the right. When you go to a decimal, you move 2 units to the left. Okay, it just depends which way you're moving the decimal. Okay, so now we can do the time to double part because now we have enough information for this one. So you had to do the percent rate before you did the time to double. The time to double, we didn't have enough info. Because you would only know A and P and you wouldn't have known R and T, and that would have been too many unknowns. So you actually had to do this in this order. All right, so here we go. Time to double. If you start with $500, then to double that would make that 1,000. Let me not put the symbol in there. So that would make it 1,000. That's doubling. Again, once you know P or R, they're fixed for all the problems, all the applications. So R here is 11% for any problem in this particular scenario, and we're looking for T. T is the unknown in this case. All right, so let's solve this one. We're going to divide off the 500. We're going to take the ln of both sides. That again allows us to bring the exponent down in front. Ln of E is equal to 1. Okay, you're almost there now. You're just going to divide off the 0.11. Okay, so time, I would either do that to the unit or the 10th place or the 100th place, but I wouldn't go past that in terms of estimations. Okay, so this again, be very careful because when you put it in the calculator, you want to close the 2, because if you don't close the 2, you're also going to be putting the 0.11 in the log, which you should not be doing. The 0.11 is not in the log. Alright, so let's do another one of these just so I can be real clear that you've got it. As part of this next exam is going to be testing your calculator skills. Oh good, this answer is also very nice. So T equals to 6.3 years. So that's how long it would take for the money to double. 6.3 years. Okay gang, I hope you enjoyed this example. I'm probably going to move on to something a little different in terms of examples on the next one. Alright, catch you in the next video. Bye.